Hello everyone, here is the rest of the notes for section 7.3. We're going to look at how to calculate sample size. So if we took the margin of error, the part that we add on to and subtract from p hat from our formula for confidence interval, and we rearranged it and solved for n, this is the result. So the formula for sample size is n is equal to the product of p hat and q hat times the quotient of z sub alpha over 2 and this error squared. So that's a formula we're going to be using. Remember, we're always rounding up. So two situations to consider. If some approximation of p hat is known from a previous study maybe, that value can be used in the formula. If there is no indication where we can calculate p hat, then we simply just say p hat is going to be 0.5. P hat and then q hat would also be 0.5. So if you notice in this formula, kind of like what I mentioned when we found the sample size from previous sections, in determining sample size, again, the population size is irrelevant. Only the degree of confidence, because that z sub alpha over 2 depends on our knowing or picking the degree of confidence, and the margin of error are necessary. So we'll just go through two examples. I'll pause the video if you need more time copying this down. All right, so in this example, a researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. Again, pause the video to finish copying that down. All right, and if you need more time, just pause again. But here, p hat, what do you think that will be? That's the 40%, so put that in as 0.4. That means q hat is going to be 0.6. This 2% is E. And then 95% tells us Z sub alpha over 2 is going to be 1.96. Again, you could recalculate that using menu 553, or you should just go back to your list because we wrote out 90, 95, and 99%. So then N is going to equal 0.4 times 0.6 times the 1.96. Now the 2% we have to put in as a decimal, and then we'll square that. And go ahead and calculate that. And again, rounding to 2, actually rounding up in this case. But first I'm going to write out what this is equal to. And we should be getting 2,304.96. So then we would say the minimum sample size is 2,305 people. All right, so in this case, the p hat, that percentage there was already calculated from a previous study. And let's look at our second and last example. This is a fun topic to explore. A researcher wishes to estimate the percentage of M&Ms that are brown. He wants to be 99% confident and be accurate within 3% of the true proportion. How large of a sample size would be necessary? So if you want to pause the video and then do this one in its completion, see what you come up with. I will point out we're only given a 99% confidence level, and 3% is the accuracy that he or she wants to be within. So what do you think that means for p hat? Go back to earlier in the notes. And pause the video if you need more time. So in this case, if it's not known, p hat then is just 0.5, which also makes q hat 0.5. So that's what we have to be aware of. So now our formula, n is going to equal, and the fact that we're at a 99% confidence level means z sub alpha over 2 should be 2.58. So n is going to equal 0.5 times 0.5. And then we'll take the 2.58 divided by 0.03 and square it. And it looks like for this we are just getting 1849. So no need to round. That means our sample size, or the minimum sample size, is 1849. All right, so I am posting worksheet 7.3. Feel free to start on it today, and then I will give you guys tomorrow to work on it as well. Let me know if you have any questions.